Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay. Today in our class, we will be discussing about atmospheric pressure. In the previous class, we have already discussed about what is thrust, what is pressure. We have also briefly discussed about Pascal's law. So these various things have been already covered, and we have also done some numericals based on those theories that we have covered. Today we will be talking about atmospheric pressure. So first of all, what is atmospheric pressure? For that, let me just remind all of you that we have already talked about pressure exerted by a fluid column, isn't it? So what is atmosphere? Basically, atmosphere comprises of air, that is gases, various gases, combination of various gases, composition of various gases. Now obviously, when we have talked about the pressure being exerted by a fluid, definitely fluid means both liquids and gases. So obvious fact that as liquids exert pressure on a certain wall of the on the walls of certain containers, definitely the gases can also exert pressure on the walls of a container. Now think of the fact that our earth is surrounded by atmosphere, a layer of atmosphere, and that layer of atmosphere contains various gases. So definitely those various gases must be exerting certain pressure on the surface of earth as well as on the various objects present on the surface of earth. So what happens when we consider our earth? So just let us understand this fact through a simple diagrammatic representation. If say this is our earth, okay, and the earth is being surrounded by atmosphere from all around, okay. So definitely like this is circular, in a circular manner all around the earth there is a layer of air, okay. Now this layer of air, definitely what happens, it exerts certain kind of force on the earth surface. So this is the earth, okay, and on the earth surface definitely the air present all around the earth will be exerting certain kind of force on the surface of earth. And if we consider that force to be acting vertically or perpendicularly on the surface of earth, and it take a particular cross section on the surface of earth, say this one of the cross section, and if it is an unit area, then definitely we will get a column of air above that particular surface, okay, just this part. Now this column of air, as we already have studied, that a column of liquid exerts certain pressure on the wall of the container or on the base of the container. In the same manner, this layer of air will also exert a certain kind of force on the particular surface of the earth. And if you consider that particular surface area to be unit, to be 1, say 1 meter square, then definitely we will get the force acting on, or the thrust acting on 1 meter square of the earth's surface due to the air column, and that is the pressure, or in more specific term it should be regarded as atmospheric pressure, as because this pressure is being exerted due to the atmospheric gases present above the earth's surface. So in simple words, this is the atmospheric pressure. So I think all of you by now understanding this concept can define atmospheric pressure. So how can we define atmospheric pressure? It is we can regard this as the thrust exerted per unit area on the earth's surface. So definitely this is a kind of thrust, because we have already learned that while we are defining pressure, it must be actually for thrust per unit area. So it's basically thrust exerted per unit area on the earth's surface by the column of air above it is called the atmospheric pressure. This is the very definition of atmospheric pressure, okay. So if you want to just write it down, you can write it once, because this is given in book, we are just still recapitulating it, okay, so that it permanently sets in your mind, okay. So if you want, you can write it down once in your copy. I think you have all kept your pen and copy side by side, okay. So basically the thrust exerted per unit area on the earth's surface due to the column of air present above it is regarded as the atmospheric pressure. Now, so this atmospheric pressure, so there must be a question arising in your mind that how can we get a proof of this atmospheric pressure, or how we do not feel any effect of this atmospheric pressure on ourselves. But you are saying that yes, atmospheric pressure exerts. So can we consider any experimental activity which demonstrates this pressure? present around us every time? Yes, that is definitely an experimental activity. If you take a certain tin can, okay, if you take a certain tin can, this is called the tin can experiment. This is a tin can with a small hole in it, okay, with a small mouth and with a tightly fitted cap, okay. We have taken here water in this tin, so we have taken a certain amount of water in this tin, fine. Now what happens? We are using a burner to heat this, okay, we are using a burner to heat this, okay, to heat this tin can, fine. Now when you are heating this tin can, what happens? When you are heating this tin can, the water slowly turns into vapor. Now initially the cap of the tin can is lid of the tin can is kept open, so that the vapors are being formed, and you can easily see that yes, the vapors are being coming out of the can, okay, like this, okay, fine. Now here what happens, whenever water is turned into vapor, it expands, because we know that gases occupy more volume than a particular mass of liquid. So the gases, the water vapor now will occupy more volume, so this entire space of the can is being filled with vapors. Now under this condition, if we just carefully put the cap back onto the can, it must be done very carefully, as because hot steams are getting out, protection must be taken. It is better not to try at home on your own, because it might cause injury, okay. So it is better if you perform these kinds of activity, it should be under the supervision of any guardian present in your home, okay, fine. So if you just take a cloth or wear some certain kind of rubber gloves and put this cap or lid on the mouth of the can, okay, and then we stop heating, okay, then we stop heating, so the flame is being turned off, put off, and we stop heating. Under this condition, if we suddenly splash some cold water on this tin can, if we splash some cold water on this tin can, what happens? It is observed that the tin can gets crushed, okay, the tin can gets crushed like this, something like this happens, okay, it gets crushed. So why does this get crushed like this? So what is the possible reason coming to your mind? This happens as because whenever you are splashing cold water from outside, what happens? The vapor that was formed is quickly turned into liquid water. The liquid water now will occupy less space, and obviously there will be some vacuum space created in the tin can inside. So now the vacuum space, there is no liquid or no vapor, so there are no molecules to exert pressure from inside the walls on the walls of the container. However, the atmospheric pressure is still acting or still present, and that atmospheric pressure being excess than the pressure acting inside the can, what happens? Crushes the tin can. So this very experiment demonstrates that yes, atmospheric pressure is being continuously acting on us, but we are not feeling it. Why we are not feeling it? Because we are habituated to this pressure from our childhood. As soon as we are born, okay, from that time the atmospheric pressure starts working on us, and we slowly get habituated to this atmospheric pressure. So we are actually not feeling it in the normal conditions. Now there are certainly many applications of this atmospheric pressure, and we can utilize the existence of the atmospheric pressure to our advantage. How? Say when you drink some soft drinks using a straw, okay, you are say drinking lassi using a straw. What happens then? Say this is a glass, okay, containing some kind of say any liquid drink, okay, it may be a soft drink or it may be lassi, anything else, okay, like this, fine. Now what happens when we drink this liquid using a straw? So say this is a straw, we put our mouth in on the open end of the straw, and we just suck out the air from this straw. Yes, isn't it? We suck out the air from this straw. Now the atmospheric pressure is already acting on this open surface of the liquid, isn't it? Open surface of the liquid. What happens? This atmospheric pressure, when we suck out the air from this straw, the inside of the straw is empty, it becomes vacuum, something like vacuum, and this atmospheric pressure causes this liquid to just rush into this straw, and the liquid goes up all through the straw and we are able to drink the liquid. Okay, so this is the very basic concept that is being used while we are drinking any liquid using a straw. Okay, so these are very simple applications. In the same way, what happens when we are taking, or when you are just taking some medicines into the injection, okay, injections that are being used, or this, or you can say also syringe. Okay, what happens in the syringe also, something like this is happening. Okay, what happens? So the syringe is something, if we just magnify the view and draw it, the structure is something like this. Okay, there is a piston like structure here, and there is a bottle. Okay, now what happens? So here is the needle present. Okay, fine. Now what happens when we just move this syringe piston up in the upper direction? What happens? Okay, it will suck in air. But if you move this syringe piston in the downward direction and just move it up to here, what happens? All the air that is present in this tube is being pressed out, is being forced out. Now, under this condition, if we just take this syringe and insert it into the bottle of the liquid medicine, and then if we just move this piston back up here, what happens? A vacuum is being created here. There is nothing, there is no air here. So when you are inserting this syringe into the liquid, okay, what happens? Due to the vacuum in the syringe, the liquid will move up. Why? Because the atmospheric pressure is acting over this liquid surface, and through the syringe needle, the liquid will slowly move up and fill up the entire space of the syringe. So this is how actually the liquid is being filled, or the medicine is being filled into the syringe. Okay, using the fact that atmospheric pressure is existing all around us. Okay, so there are many more applications present in the book. I have just discussed two of the applications so that it is easier for you to understand. Okay, so please go through the other examples. If you have any doubt, you can mention in the comment box. We will be discussing those specific doubts in the next lectures. Okay, so fine. Or if you just mention it in the comment box that these examples are not being understood, then definitely we will do another separate video and explain those examples. Fine. Now, next thing that we need to discuss, or we will be discussing, is how do we measure this atmospheric pressure? What is the instrument called with which we can measure the atmospheric pressure? What is the value of the atmospheric pressure? Okay, it's the instrument that we use to measure this atmospheric pressure is called barometer. Okay, so barometer is the instrument that we use to measure the atmospheric pressure. And if we see, there are three kinds of barometer. One is called the simple barometer. Okay, second is called the 14th barometer. So it's 14th barometer and 14th barometer, and the third one is the aneroid barometer. So aneroid barometer. Okay, in simple barometer and 14th barometer, the some liquid is being used, and that liquid is, in most of the cases, it is taken as mercury. And in aneroid barometer, there is no liquid present. It is based on a little different principle. Okay. So now, if we just consider the principle or the working of the simple barometer, let us see how does the simple barometer works. Okay. See, for a simple barometer, what happens? Okay. So in simple barometer, we take a test tube and a trough. Okay, we take a test tube and a trough. This is an open trough. Okay, and mercury is present in this trough. Mercury is already present in this trough. Fine. Now we take a test tube. We suck out the air from the test tube and put our thumb over the test tube like this. Say if this is test tube and this is the opening of the test tube, we suck out the air like this. Okay, and we put our thumb over this mouth of the test tube, open mouth of the test tube, and then we insert this test tube slowly like this into the mercury, and by removing our thumb and gently press it into the mercury. Now when the test tube is being put into the mercury column, the mercury present in the trough, what happens? The inside of the test tube is almost empty. Now what happens? Atmospheric pressure is acting on this open surface of the mercury. This atmospheric pressure causes the mercury, or pushes the mercury up into this test tube. Okay, it will go up to a certain level and it will stop. Why it will stop? Because see, whenever the mercury is going up, it is forming a liquid column, and as we know, a liquid column also exerts certain pressure. Definitely this liquid column will start exerting some kind of pressure, and as we know, the pressure exerted by liquid column increases with the height as the mercury column goes up. So the height increases in a certain height. This pressure exerted due to this height of the mercury column becomes equal to the atmospheric pressure, and the liquid stops flowing up. Okay, so from this simple arrangement, how can we get the exact value of the atmospheric pressure? We will be discussing the numerical process in the next class. Okay, so in our today's video we will be stopping here. Please do study this through your book, go through your book, and if you have any query, mention it in the comment box. We will be happy to solve the problem. So today we will be ending our video. Till the next video, please do study well. Thank you. Goodbye.